there's about 170 students, and we've got over 100 industry partnerships. And we kind of collectively put all the researchers into these 4 centers. So population disease, superbugs solutions with microbiologists, cell biology and chronic disease, and chemistry and drug discovery with all the lovely creepy crawlies. And that research kind of falls into a number of different categories in health, disease, agriculture, pain, cancer, inflammation, endometriosis. And so already you should appreciate that we have a very broad bunch of people that we have to support just in-house. And so our facility, there's 2.8 of us, or 3 of us, and we have about 20 microscopes. We do a lot of big data visualization and have servers, remote VMs, about 175 users, and we do over 150 user trainings a year with about 55 projects. So we're a light microscopy core facility. This is just some of our equipment that we have and some of the kind of outputs that we have, including developmental biology, cell biology, long-term time-lapse imaging, which makes a lot of big data, and like high-speed lattice light sheet imaging. But we also support a broader community from around Brisbane with different research projects like electrical engineering, and automation and creating tools for animal vision and ecology studies, dentistry, and mammary calcium signaling and scripting and writing analysis for. So the typical workflow for the people coming into our core facility, they want to do their experiment, take a picture, and then publish it, hopefully. They don't really think about the full pipeline, which involves extra things like doing the analysis and visualization. And so when we think about bringing in multiple different experts to support this kind of pipeline, there's lots of different stakeholders. So we have the group leader who's driving the research project. We have funders who are either paying for that research or paying for the equipment that research is done on. The facility staff, like myself, who support this. The IT kind of in the building, supporting moving data around. We have vendors, whether they're hardware or software. We have the research computing division, which is supporting the bigger scale computing like HPC. We have things like the library and the data management platform. We have the community-driven standards, such as like what this group's trying to do. And then we have the repositories and that who want to take the data. And underlying all of this is this need to capture kind of rich metadata along the way. And so as a core facility, sometimes I think, we're kind of like the grease or the, keep the science going. So how do we be low friction? How do we keep everything moving and hopefully minimize breakages, whether they're kind of physical, software, or emotional? But we're really positioned to see all the bottlenecks, see the pinch points, see where we can have improvements possibly. But I'll caveat that with there's 3 of us in our facility, so we can't do a lot. But we can kind of promote behavioral changes through doing trainings, advocacy at the user level, build collaborative or collaborations with the stakeholders to make tools and solutions that hopefully speed up the process, and work with partners to develop and implement policy guidelines like metadata standards. So thinking about the process, what are some of the tools that our users might be exposed to? So we've heard a little bit already about lab notebooks, and that's come up in some of the discussions yesterday afternoon, and things like LIMS and laboratory inventory management systems. That's kind of at the university level, they do that. We have acquisition, so we can read the metadata from files, but there's all this extra sample metadata, and so I've built a little tool that's trying to promote our users to think about that, and I'll talk about that in some future slides. On the analysis and visualization side, we have remote servers, but we've also built this thing with RCC, the Research Computing Center on campus, which is called the Image Processing Portal, and I'll talk about that one as well. And then on the publishing side, we've heard about UQ eSpace, which is a repository system, the data management platform where we can share data as well, and different impact trackers, ORCIDs, things like that we've also heard about. So one of the things that I was thinking about with capturing this metadata is that the users are sitting at the microscopes often with 5-10 minutes between acquisitions, and how can we have a kind of prompt them to start thinking about metadata? Because I can guarantee that probably none of them are really thinking about recording things properly. I do a lot of image analysis with our users, and I see GFP written every way possible. I see, countless repositories of image 1, image 2, image 3. So, or like the comment where everything's stored in the file name. I see that a lot too. So how can we begin coaxing our users into doing this, or thinking about these extra experimental metadata tools or captures? So my thought was, get it while it's fresh in the mind. Asking the biologist to do this, tomorrow or next week, it's not going to be as accurate, not going to be kind of rich. So where can we collect things like, well, what was the mounting media on the sample? What was in the media? What drugs were added? What compounds, antibodies, what construct even? A lot of that's not well thought out by a lot of our researchers. And as I said, there's often free time. So I built this tool that I called Remind. Basically, it's a Python GUI. And it's kind of simple enough that it spits out like a text file as well as JSON, XML, whatever format you want, key pair values for a mirror. But the users can fill in information. We have RDM, so I built a platform or a version that works with the UQ systems where they automatically can drop down all of their projects that they're working on, and then it populates fields relevant to that. And then they can write information about it. They can also open up a file that they've captured on the microscope using a lot of those readers I spoke about earlier, and it'll populate the rest of the fields for them. And they might want to make notes, because often our users are adding a drug, doing some stimulation, and they might need a space to write down, and it's not a scrap of paper in the lab. So, and then I thought, well, most of our researchers do the same thing each week and don't really change much, so we made it that you can load templates and make it a bit easier. One of the side benefits that we found was that because it's spitting out something that's also text-based, the operating system search things can find it. So we thought this is a good selling point to the group leaders, one of those other stakeholders, because now they can search for that honest student and a couple of keywords about the experiment and find where the data is in these vast troves of different RDMs that we have. So hopefully I want to make it so that, like we heard yesterday with Pitchy, if you've set it that this is the project I'm working on, we know where to store it. We could orchestrate moving that automatically. So that should be pretty trivial. So the other thing that we are talking about today is our image processing portal, which is a GUI for HPC. So we can have a website that's linked in with all the university platforms. They log in with their university credentials, but there's no command line. And why do we need this? Well, we've got a lot of camera-based microscopes, and they're making a lot of data. So here's some of the collections, where they're making 50 terabytes over a 2-year period, or even making 30 terabytes in about 2 weeks. The university network is pretty complicated, so it's teaching our users how to navigate that can be challenging, and it's not really viable to have like a workstation, and the university doesn't even allow us to buy a workstation PC anymore. So how do we kind of make it so that it's easier for the users to process and manage their big data? And it's not a kind of problem that we can solve now, because there's new cameras coming with bigger data, there's new microscopes coming that are going to make a scary amount of data for a biologist at least. So this is our portal that we made. It's, as I said, just a website that they log into. It integrates file browsing, so now our users can move big data around. They don't need to know what rsync is. They don't need to, configure the file path strings. They have a pretty browser, click files, they can view files and access them, rename them, do that kind of stuff. We put in a bunch of different image processing tools like image deconvolution, file conversion, the ability to execute macros. We can connect into the open on-demand visualization environment. And it works with like little wizard pages, so the users move through steps and we can auto-populate those with the metadata that we're reading. So like if in the case of deconvolution, none of my users know what a back projected pinhole radius is, but we can calculate that from the metadata. So, and then also the benefit is it provides like a receipt and job tracking, and we know what settings users use, so we can keep that metadata and have it, because if you ask the researcher, how many cycles of deconvolution did you use on that data set 6 months ago? They're not going to know. But if we capture that information, it can be stored. And so yeah, most importantly, since everything's like a job now, we have these receipts. And so there's lots of stakeholders in this project. Probably everyone who's ever worked at RCC has been involved at some stage. We previously connected out with the CVL desktops, so we, ARDC and some of the other unis around we're involved in discussions with. Now we're on Open on Demand. We've worked with vendors, so 3i, MRS to make file converters, Microevolution, Huygens, and then we have connections out to our booking platform now, so we can do billing and information and tracking, user statistics, things like that. And then we have our end users, whether they're other facility staff members on campus, researchers or students, and we've had other people from other universities in Australia globusing the data to us, processing it, and then globusing it back, which surprisingly some of the commercial software licenses do allow. So the kind of low friction approach we've taken is we want to make sure that everyone's happy. So the researchers have a way to process their data and are pretty happy. The RCC is happy because people are using their infrastructure, and more people using the HPC probably translates hopefully to new shiny toys for them. We provide a bit of financial support for the projects that they work with us. As a facility staff member, great. I don't have to troubleshoot 175 users, command line spelling mistakes and things like that. Maybe less important, the vendors always get these questions. How do we process data? So we've had other reference sites, come see us and say, oh, we would like to know what you're doing. And, commercial platforms that we pay licenses for. But that's not to say that it's not challenging. The biggest barrier dealing with all these different customers is language. Talking the same language, ensuring that there's this common vocabulary. I found it's really important to detail every process, why we're doing it, why this is important, why this one field of the metadata that might mean nothing to everyone else is important. And changing user behavior can be hard, so we can make these wonderful tools and then adoption can be slow before, I find researcher to researcher communication is way better than facility staff to the researcher. And yeah, the early adopters see benefits, and then that kind of drives uptake. So it does get used. There's lots of papers coming out using it that are, making terabytes of data and can process it. So we promote and disseminate this knowledge through kind of two directions. Top down, so we train the users. We do one-on-one trainings, we do workshops, seminars, things like that. But then we also do side-to-side training. So we have a community of practice at the university where we involve all the other core facilities, whether it's flow cytometry, people managing the glass houses. They often have data problems, user problems, training problems, acknowledgement problems, and we're discussing those things in our group. We've engaged with broader national imaging facilities through Light Microscopy Australia. We have an annual kind of facility managers training and cathartic session. And then we try and participate with the network organizations to implement these policies which align with our strategies and the emerging trends. So in conclusion, the core facilities, I think, are really well placed to deliver on these things that are discussed at these meetings. We have relationships already with lots of different stakeholders. We build tools that aim to be low friction, because biologists don't want to learn new things. They don't want to be told that they have to do 5 extra tasks. They're going to take them more time. Where possible, these tools should be somewhat interconnected, so that we're not like reinventing the wheel. And it's impossible to tackle these things on their own, so we've had to involve RCC and other things, and stakeholders, and yeah, definitely that common vocabulary is really important to keep everyone on the same page. 2 quick plugs if you like talking about light microscopes. We have a whole week planned next year in Sydney, and if you're into HPC stuff. I've got this open call for publications, but these are some of the people who've worked on that project as well, and happy to take questions.